Hello, and welcome to another exciting episode of Web Technology. I'm your host and your professor, Dr. John Baugh. For this lecture, we're going to be covering web technology, or database technology rather, for the web. And we know that web applications are built on two main parts: what the user sees and what the application knows. So the HTML, CSS, and JavaScript define the layout and the appearance that users interact with in their browsers. The data that drives the content, such as products, users, blog posts, recipes, or comments, is usually stored and managed by a database system. In early web development, small websites often kept their information in plain text files or simple arrays within scripts. As soon as multiple users needed to access or modify data at the same time, these approaches became unreliable. Data had to be organized, validated, and shared safely, and this is where database systems became essential. A database provides a consistent, centralized way to store, retrieve, and update information. It also enforces data integrity, ensuring that stored values follow defined rules and relationships. For example, if a recipe is deleted, its ingredients should not remain behind as disconnected records. Databases handle these details automatically when properly designed. In web development, the database often serves as the backbone of the application. The code acts as a bridge, sending queries and commands to the database, and then using the results to render dynamic pages. When a visitor views a product, leaves a comment, or logs in, those actions involve database reads or writes behind the scenes. The examples in this lecture are going to focus on two major categories of databases: relational databases and NoSQL databases, or NoSQL databases. For relational databases, systems such as MySQL, MariaDB, Postgres, and SQLite organize data into tables with rows and columns using keys to link related records. These are the backbone of many traditional web applications and form the focus of the first examples. NoSQL databases, like MongoDB, store data in a more flexible format, often as documents, in a JSON or JavaScript object notation like structure. These are common in applications that need to handle large volumes of unstructured or rapidly changing data. The first part of this guide is going to use XAMPP, which includes PHP, MySQL, and Apache Web Server. This environment allows you to run and test database-driven web applications locally, without the need for an external host. Later, we will demonstrate a NoSQL example using Node.js and MongoDB. Throughout the guide, the emphasis is on understanding why each step matters, not simply executing code that works. You will design a simple schema, run queries manually in PHP-MyAdmin, connect to a database from PHP using PDO, and later compare how a NoSQL model stores similar information. The goal is to understand the database as an integral part of a web application rather than a separate tool. Once this connection is clear, it becomes easier to see how real-world systems such as blogs, online stores, and streaming platforms manage their data efficiently and securely. All right, starting with example 1, we're going to work with a recipe share with MySQL, PHP, and PDO. All right, so the outcome is that we will have a list of recipes at /recipes, recipe details at /recipe PHP, and then $ID equals. That will show the ingredients. Author stats at /stats_authors.php using our group by command, and all lookups use prepared statements. All right, so step 0 is our prerequisites. So we should have XAMPP. I have XAMPP installed already. This is what it looks like right here. And I have VS Code running in the background. So VS Code extensions you might want are PHP IntelliFence. It's like a better PHP IntelliSense. PHP Debug, optional Xdebug integration if you enable it in XAMPP later. And Editor Config or Prettier is optional. I already have those installed through the extensions, but you can see PHP debug here, and then PHP IntelliFence should show up. I've got this already with an elephant, of course, part of the joke. But these should help with how the code is structured and viewed in the IDE or the environment. Alrighty. So the first thing we're going to do is look at XAMPP. Okay, so XAMPP creates a top-level directory, and that goes inside C drive, typically. And in C drive, there's a folder called XAMPP. Underneath this, there's one called htdocs. And by default, that is where XAMPP is going to deliver or serve the different files. You can make subfolders if you want. So what we're going to do is we're going to create one called recipe-share. Okay. So I've got a bunch of other stuff in here already, but it has to be recipe share inside of htdocs. Okay. I'm going to go through VS Code and tell it to open a folder, and I'm going to tell it to go through that location. So C:/ and then XAMPP, htdocs, and then recipe share. Okay, I'm going to select that as the folder that I'm working out of. All right, so we're going to edit our files here so that Apache can serve them directly. Now, we're now going to look at XAMPP. XAMPP. So we've got XAMPP open here, and we're going to start Apache right here, and it should turn green unless you have a port blocked, which you can modify which port it's using in the config, or MySQL. Okay, so we want both of those running. And just to make sure that this is working properly, I'm going to drag this over here, and we're going to go to localhost. I think I have it on 5,000, but it might be on something else. Maybe it's something else. I think it's just localhost. Let's do that, actually. I think it's on port 80, so that's the default. So let's do that. Yeah, there we go. Okay, much better. You can create a quick test file inside of VS Code just to make sure this thing works. So I'm going to right-click here, go to New File, and say info.php. All right, so inside of info.php, I'm just going to, I could type it or I could just paste it just to save some time. It's a PHP and then PHP info. So this actually opens it. You could put a closing brace right here, and it may go against your better sensibilities as a developer, but it's actually recommended in PHP that unless you have non-PHP content following it, you actually omit the closing angle bracket question mark. Okay, so we've got the recipe share is at the top level here, and then info.php. To make sure that this works, I'm going to go in here at localhost. It's going to be localhost / recipe share / info.php. Okay, and it will show that PHP is installed and everything's working right. So if the PHP renders, you should be good. Step 2 will be to create the database in phpMyAdmin. So before we do that, it would be important that we know what an index is. So what's an index? An index is a data structure that allows the database to locate rows faster without scanning the entire table. You can think of it as like the index in the back of a textbook. So instead of reading every page to find tomato soup, you go directly to the entry that tells you which page it's on. In MySQL, indexes or indices are usually implemented as balanced trees or B trees if you're a database person that likes databases. Or data structures rather. The tree keeps the column values sorted internally, so lookups, inserts, and updates can be performed efficiently. So we're going to go to localhost / phpMyAdmin. Now this automatically comes with the XAMPP, so phpMyAdmin, and it logs you in. And you're able to create databases and users and all kinds of fun stuff here. You notice I do have some databases in here that I had for my tests that I was running just to make sure that my example code that I was creating worked and everything was pretty. So you're going to click databases here, and Under here, you're going to go to the create database, and I'm going to create one called just recipes_db. And you can use the default collation, which is just UTF-8 MB4 general CI. Click create, and then you'll have the option to create tables. Okay, now we could do this manually this way, or you can do it using SQL. So once you have the database created, you can just open the SQL tab right here, and I'm going to paste in the SQL right here. Now I will provide this with the video so everyone can access this entire document that I'm using. I'm actually, most of it I'm reading off of it. It was just to keep me on track and to make sure that all the code's good, and so you don't have to, follow along and watch me type the whole flipping thing. But if you want to get some of the muscle memory under your fingers or whatever, you can pause the video at any point and just do it that way if you'd like. So just note that, pause it and get these tables in. We've got recipes and then also an ingredients table. Then you have the index to help with the joins, sending the data or seeding the data. And we use insert in order to do that. So the created the tables, create table, but insert is very common because we use it to actually put data into those tables. So we created a recipes table up here, an ingredients table. Here we're inserting data into those. So the table has, for example, IDs. It has name and amount. The other ones many of these are auto-incremented or created automatically. But for these, we have the title and the author. We're putting, for example, classic tomato pasta by Alice Brown, lemon herb chicken by John Doe, etc. So we're going to run this, and as well as ingredients as well. I'm going to hit go, and you'll see that it shows that MySQL actually created all this fun stuff. And you should get, hopefully, no errors. Now, you can look under structure. You can actually browse the ingredients in here, and it'll show you all the data in here, which you can modify from here. And you could also go back to structure or browse and then look at, you can actually change the recipes database, look at ingredients, okay? And you can see like the corresponding recipes that they belong to, their own ID. So this would be like the primary key within their own table. And then this is a foreign key, which is referring to the external key from the other table. And then the name, of course, and then how much you need in that particular recipe. So we now basically have the schema and the initial data for this. We're going to store now DB connections, connection settings. So inside of here, inside of my recipe share, I'm going to create a new folder called protected, if I can spell it, and have my fingers on the home keys. Okay, we've got protected. And inside there, I'm going to create a new file, and I'll call that config.inc.php. All right. And for this one, I'm pasting this right here, this content. You can see that we define the host as localhost. The actual database name is recipes database. DB user is root in this case. Normally you wouldn't want to do that. You'd probably not keep that. You'd probably create another user for that, but for our purposes, it's okay. No password, obviously. The default, you want to have actual passwords, otherwise there's no security. If you leave everything default like this in a production environment, you're going to get fired. I'm just letting you know that. So, and then we define the DB connection string, and it's MySQL host equals, and then you concatenate. That's how you concatenate in PHP, is with the dot, DB host dot, and then the semicolon, DB name equals dot DB name, and then charset is UTF-8 MB4. So that's just the encoding for the actual text. Again, security notes: do not keep secrets in web-served paths, and for the class demos on localhost, this is acceptable. All right, now you're going to create another folder at the top level. So protected is one folder. We're going to create another folder and call it lib for library. Right-click, you're going to make database.php capitalized. And again, we're going to put in some code right here. Again, you can pause at any time if you want to copy it. But you'll notice it's looking at top level of our project, or current, and then up into protected, and then config inc PHP. So it requires that, given the directory structure, our current dir working directory at the top level, recipe share, and then slash dot dot protected, config inc PHP. Then we create the PDO. Okay. And PDOs are PHP data objects, which is basically an abstraction layer for databases in PHP. And it provides lightweight, consistent interface for accessing various databases like MySQL, Postgres, SQLite, Oracle, etc. So that's basically its purpose. It's just an abstraction layer so we don't have to deal with the nitty-gritty of each database type. But that's what we do. We create this with the connect function that we're defining here and return that PDO object that we can then use. That'll keep our scripts cleaner. Now at the top level, again, I can minimize that or collapse that. I'm going to create at the top level recipes with an S at the end. That's important because we'll have one that doesn't, .php. I'm going to copy and paste the code here. It's not crazy long, but you'll notice that we are requiring the database file and then connecting. Then, of course, creating the query as a string in PHP. So we're selecting recipe ID, title, author, created at, and we tell it from which table, which is recipes, and then order it. Then we use the PDO object to execute the query, and then recipes equals that statement, fetch all, and then we do close it here because we have non-PHP code down here. Then you can open and close the PHP as needed right here. So this is basically opening and creating a for each, recipes as R. So each R represents an individual recipe. We go through, create the link dynamically so it points to the right recipe. And any dynamic data you're pulling in, you should be using HTML special chars. Otherwise, it could have some security problems. Okay, so you always want to escape them with that. And then at the end here, you'll notice for single line PHP, we just use question mark equals. You can do that. But anything bigger than that, you can actually open and close the PHP. I think we could do n for each there too, but regardless, we've got all this here. And then you're mixing the HTML in with the PHP, so we do put the closing question angle brace. All right, the next thing we're going to do is I'm going to visit the recipe share recipes off of localhost, so that we can see what it looks like. Okay, localhost / recipe share / recipes, and not getting anything. Let's see if we saved the file. We did not save it. So that little white dot means we didn't save it. Control S, we got to save it. Hit it again. There you go. Okay, so I'm going to increase that so you can see that. I had opened the developer tools real quick, but we don't need that right now. Classic tomato pasta. You notice if I click it, it says URL's not found because it's trying to call on a file called recipe, no S, .php, and then it's passing in the query string with the ID equal to 1. And then the next one, lemon herb chicken, ID is 2, and then ID is 3 for the veggie chili. But it's not finding any of those, right? Because they don't exist. We have not created that file to handle those recipes. So we need the recipe detail page now, okay? So that's what we're going to do. We're going to create the recipe detail page. So I'm going to right click here, go to new file, recipe with no S on the end, .php. And this one, I'm going to copy the code, put it there. I'll slow it down so you can pause the video and copy if you want to. So I've got this part up to line 29. And then we'll go there. Okay. And then that's the end of that. So you'll notice we're again connecting to the database after requiring. We're filtering input. And the ID is what's being pulled in as part of the get, because it's passed in as a query string, and we're just filtering it and trying to get an integer out of it, and it should have the ID, it should have the name ID. And if that ID doesn't exist, we say invalid recipe ID. And then if it gets past that point, it should be valid. So we're trying to select from the database the recipe ID from the recipes where the ID equals that ID. So that's our prepared statement. It's ready for the ID and the PDO prepare. We call that. And then we pass it in with the ID set to the ID that's passed in from the parameter, and then execute it and fetch the recipe. And then if the recipe doesn't exist, recipe not found, if it does, then we pull in the ingredients and we bind the value, and then we basically print out all the information about who made the recipe, what are the the amount of the specific ingredients. That's why there's a for each here, because this could be several ingredients, right? So we have amounts and names. That's part of the ingredients data, table. So now we're going to create a statsauthors.php. Okay, and let me copy over the code from there. There you go. Now this is probably in bad taste. We could use CSS, but we'll leave it for now. So require once dir lib database. We connect again. This time we grab the author and find out how many recipes they have, right, using a count. From recipes, group by the author, and then show the recipe counts. And then we have the statement grab the PDO query. Again, grab the rows from the statement that are returned, and then we print them out, essentially. And there's always a back to recipes kind of navigation button. Okay, we're going to save that. That should be good. So that page will just validate the input and use the prepared statements and print the escaped HTML. We probably want to create an index.php because that's the starting point of essentially pretty much any website is an index, the index, not to be confused with database index, but index.php. So PHP, we include the header, location, recipe. So it automatically takes you there. And now just to make sure that it jumps to it properly, we're going to go to our Chrome right now, or browser of choice, and then go to localhost/recipe-share, hit enter. There's recipes again. That's what we saw before. But now when I click on them, I actually see this information, right? I see all the information. And then I can look here, get lemon herb chicken, veggie chili, back to recipes. So it's really, really handy, really, really cool. Okay, so you made sure that the URL contained numeric IDs. If we do something like this, like if I put, it's got recipe.php, if I put an ID of 6, it'll say recipe not found. If I put an ID of, say, DSA with letters, it'll say invalid recipe ID because that's not a number. It's not able to filter it as an integer. Okay, so just be aware of that. We know recipe 1's valid. We can go back to recipes. So that's all running through the database and everything's going really, really well. Some common pitfalls to be aware of and some fixes are blank page or PHP not showing us text. Apache may not be running or the file isn't in htdocs. Make sure you start Apache and have them in htdocs. If it can't connect to the database, make sure that you have MySQL running. And the headers already sent is a possible error you could get. Make sure there's no white space before the opening tag here on the PHP. Or after the closing braces when you have those. And always wrap your dynamic output, like from the database, the rows, the arrays, and things like that, in HTML special chars like we saw here. Okay, because that prevents what's called an XSS attack or cross-site scripting attack. All right, so moving forward, we're actually going to create another little product here to understand transactions for data integrity. So I'm going to close this. folder, and we're going to create a new, I'm going to go to open folder here. Where is it? Oh, there you go. Open folder. And inside of the cxamp, we're going to go to htdocs again. And in here, I'm going to create a new folder called store demo. And in store demo, I'm going to select that. And there's a couple things we're probably going to just copy over, which makes sense. So in htdocs, I'm going to go into the recipe share. I'm going to copy over the lib and the protected folders, and I'm going to put them into store demo. Okay, so they're in here now. We've got the config and all the other stuff set up for that. So we've got, config right here. In this case, we're going to change this to store DB, right? But everything else is effectively the same. And make sure that the lib looks right here, protected, config. Okay, so we have to actually create this database and the tables in phpMyAdmin. So I'm going to go back to the recipes page for now, but I'm going to go to localhost, and then we're going to go to, you can actually click phpMyAdmin and go there. We're going to create a new database. So under databases, I'm going to create a new database called store_db. And for this one, we're going to run also some more SQL. Okay, so I'm copying this, and it will also create tables. So this one has products and orders and order items. And then we have an insert into products, name, price, stock values. Okay, notebooks, pens, and backpacks. So pretty typical. So transactions. So what is this engine equals NODB? Okay, we're going to hit go. But what does that mean? So that will support transactions. Other engines, such as the MyISAM, do not. A transaction is just a sequence of one or more SQL or SQL operations that are treated by the database as a single indivisible unit of work. In simpler terms, it's a package of database actions that must either all succeed or all fail together. If any part of the transaction encounters an error, the database will undo everything that was done within that transaction so that the data remains consistent and correct. Transactions are often described by the ACID principles, which define their reliability. Okay, and the ACID principles, ACID, are atomicity, consistency, isolation, and durability. Atomicity means the transaction's operations act as a single unit. They're atomic, right? So either all of them succeed or none do. They work as a single unit. Consistency means the transaction brings the database from one valid state to another valid state, preserving rules such as foreign key relationships or unique constraints. Isolation, as the I in ACID, means transactions can occur concurrently without interfering with each other. One transaction should not see another's partial results. And durability is the D in ACID. Once a transaction is committed, the changes are permanent, even if the system crashes immediately afterward. So, step 2 is we update our connection configuration. You made sure that the store_db was used. I already changed that, so we're good. We're going to create a checkout.php at the top level here, checkout.php. I'm going to copy over my code here. Okay, it has quite a bit going on in this one, so I'm going to slow it down for you if you want to pause and copy. So up to line 28. And then down here a little bit more, 29 through 53, 54, and then the rest of the code. All right, so if we go at the top here, this is a cart example. So if the cart has, 2 notebooks, so item 1, 2 of that, item 2, 5 of that, and then item 3, 1 of those. Okay, so we try to begin the transaction this time. We're not doing it, we're doing it as an atomic unit. We tell it what to do, prepare the statement, grab the item we're looking for, or items we're looking for, bind the value to the ID, passed in, and execute. Notice there's a for each. That's because it's going through the entire cart, one at a time. And each time it's going, for example, it's using the ID and making sure it's an integer. It goes through. If the product isn't found, it throws an exception. If there's no stock for that item, it throws an exception with insufficient stock for the product. And it takes the line total, and then it uses this total variable, which we initialized to 0 before the for each loop, as an accumulator, right? So we're taking each line total and adding it to the total. Then you insert the actual order, insert into order. So this is how you track the actual order, and then insert order items and update inventory. So you go through here, select price from product, etc., fetch the columns, insert into the order items, and then you have to update. So instead of insert, we're doing an update now, right? Because you're using standard CRUD operations. So create, read, update, delete. Here we are updating, not creating or inserting, right? So we're updating products, setting the stock equal to the stock minus this quantity value, where the product ID is equal to the ID of the thing we just basically added. We execute each of those statements. At the end, it's all ready, so we commit all the changes as one and then verify that everything worked. If there's ever an exception, it rolls back the PDO, basically erases the work, and then say the transaction failed in red. Okay, so everything's still running, right? Apache and MySQL are running. If we go over here and I go to localhost store demo /checkout, I can see that this order number 1 completed successfully. We have a total of $47. And I can actually look at the structure here and see the products. And the products, you'll see how much is in stock of each, right? So you can actually see that there are 18 notebooks, 45 pens, and 9 backpacks left. If I run this again, if I refresh, it'll say order 2 completed, right? Same items. Now, if I go back to the database, refresh that, you'll notice there are less notebooks available, fewer pens, and also fewer backpacks. If I do this a few more times, right, I can refresh the database, the table, it's down even more. Do it a couple more times. Okay, refresh over here, you'll notice it's all zeros now. There's nothing left in stock. If I try it one more time, you'll notice it says it failed. Insufficient stock for product 1. Now it's not even saying anything about product 2 and 3 because the 1's enough and it's as a primary transaction, right? So why do transactions matter? Well, web applications often involve several dependent database actions. Without transactions, an error halfway through could leave partial data, such as an order without items or deducted stock without a recorded sale. Transactions guarantee all or nothing consistency. And how does this apply in real systems? Well, e-commerce checkout, bank account transfers, reservation systems, batch updates where many tables must remain synchronized. Some troubleshooting, if you get a cannot start transaction, then make sure that your tables use engine equals INNODB. Transactions are not supported on MyISAM. Lock wait timeout exceeded means that 2 scripts might be updating the same rows simultaneously. Just try to restart MySQL and try again. A blank page or fatal error, enable error reporting for debugging. Now, in summary, a transaction groups several SQL statements into one logical unit. Use begin transaction, commit, and rollback in PDO. If an error occurs inside the block, always roll back to maintain integrity. INNODB supports transactions and foreign keys. The example that we just did demonstrates how MySQL enforces the ACID property for atomicity and reliability. Okay, next up, we're going to work with comments and replies in MongoDB using Node and MongoDB Atlas. So we're going to be able to get API/recipes/ the ID and comments, returning all comments. We'll be able to add a top-level comment, use post and get. All endpoints are exercised and verified in Postman. So you have to make sure that you have Node.js 18 or newer installed, VS Code, of course, and then also a piece of software called Postman. Okay, this is Postman. It'll pop up momentarily. And you usually have to log in. So and once I've logged in, I've got my workspace up here. Some VS Code extension that would be optional but useful could be ESLint. So that's for making sure the syntax and everything works well with JavaScript, helps you. So a linter basically just helps you figure out different potential bugs that could be in your code. Static code analyzer. All right, so if we open VS Code, and I'm actually going to close this folder, because even though it's recipe related, it's a different project. I'm going to close the folder, and for this one, it doesn't really matter where we put it. So I'm just going to say open folder, and we'll go, you do not have to have it in the XAMPP folder. Okay, we could do XAMPP and htdocs if we want to. We don't have to. We could put it anywhere on the drive, but just to keep things consistent, I'm just going to call it recipe comments API. Okay. Oh, I spelled it wrong. It'd be good to spell it right. Let's make sure. Recipe comments API. I'm going to select that folder. I can actually turn off XAMPP. I can stop MySQL and Apache because they won't be served from there. I'm going to say, yes, I trust the authors. Go to a new terminal. This will bring up, you have different options in here, but if you install Git and Git Bash, you should be able to create Bash terminals. But you could always use PowerShell or command line or JavaScript debug terminal, or really whatever you want for the most part. But Bash terminals usually are really useful. So Git Bash is one. I'm going to init npm. npm is used to be called the Node Package Manager. Now it's just kind of a joke, whatever it stands for, but that creates a package.json, which we'll edit shortly. But we're going to say npm install express space mongoose space .env space cores. Those are different libraries. These are dependencies, and you're telling it to manage it for you. So instead of having to go to a website and download it yourself manually and try to install it and put it in the right folder and all this other crazy stuff, package managers like npm help us to do these installations. We're going to update the package.json script. I'm going to just do a copy paste, I think, from here. So it runs nodemon. If we tell it to do dev, it'll run nodemon, which it'll update as we update our code, and we don't have to keep restarting the server, doing it manually. I have project structure that I want, so I'm going to create a folder called .env at the very top, or a file rather. That's a file, not a folder. It's already got package.json and package lock. I'm going to create a folder called src, and the source folder is going to contain the source. Okay, so we're going to create server.js because we're doing JavaScript now. We're not using PHP for this. db.js inside src. You're going to create another folder, a subfolder called models, and another subfolder called routes or roots. Okay, inside models, create another file called comment with a capital C.js, and in routes I'm going to create a comments.js lowercase, right? We do have to create a MongoDB Atlas cluster and credentials. I've left some instructions for that, but basically you sign into MongoDB Atlas after you create an account, create a project, and then you create a free tier, which is an M0 cluster, typically. And it may appear as create deployment or build a database. You click that. And if there's any network access settings, you might have to set the current IP or 0.0.0.0.0 or /0. And database access, you can create a user with read and write to any database. Okay. You want to create a username and password. Okay, so I have, let's see here. I've got my environment over here already. There's stuff from an old one I was working on. We'll probably have to rename that, rename ours so that we can get it without conflicting. It will create it from the script on the first run, so we don't have to create it here if we don't want to. But you can look in the cluster, look all the, yeah, so right here we have this cluster. It has collection of collections, which are basically like the databases. And inside here, or the cluster can host the different um, resources that you need. For example, the databases, documents. The databases contain the um, so yeah, collection contains what are called documents. The database has the collections, and then the collections have documents inside of them. The documents are kind of analogous to rows or records from a relational database. They represent independent entities. It's really schemaless. So unlike the tables in a relational database, collections don't enforce a fixed schema. So anyway, if you look in here and I click on this, I can see just an overview of the information. If I want to, I can look at the Data Explorer and see what kind of data is in there. This is from previous stuff that we've done. But you want to make sure that you can grab the data from your cluster. So if I wanted to connect to this, you can go to drivers and then make sure it's on Node.js. Make sure you've got Mongoose installed, so you'll have MongoDB installed. And then you're going to copy this right here, which is a connection string. All right. And then we can say, okay, good. So specifically in here, I do want to put Mongo URL. Oops, sorry, wrong file. I'm going to go to .env file. Very important you name it that. And because you can create environment variables in here for your system to use. So Mongo URL equals, we've got our WebTech, UMD WebTech is what I called it. It's got the DB password and all this fun stuff. And I believe I named it, let's see here. We will go to the database and network access. I made a recipe admin. It has access to the databases, and you can edit the access if you need to, tell it what it needs, etc. Okay, so I'm going to put that in there. DB username is just recipe admin, right? Recipe underscore admin. I believe this is going to be a temporary thing, so don't try to copy it. But I believe I made the password like fudge 123, I believe. And I think everything else is right. The other things we need are MongoDB equals the recipes app. I'm going to call it 1 because there's already one with that name. And then I believe we're using port 5000. And you might have to restart your node server, possibly, if you have it running already. But npm run dev. Okay, see if it actually loads. Oh, it doesn't know what that is. Oh, you know what? I don't know. Did we install nodemon? Npm install nodemon. Make sure that's installed. Good, and then we'll see if this works. Okay, good. There you go. Now nodemon is running, and it is ready to serve it or serving it. Waiting for changes before restart is what it says. So we should be able to go to the site once we have some stuff there. So the first thing we're going to do is under the source db.js is I'm going to put some code here. Again, I'm going to save it. You can pause as needed. Okay. But for this one, we also need a source models, the comment.js. Okay. So this one's going to have some code in it as well. We see that we have the reply schema. We use Mongoose for this. We tell it the different things about the information that we need for this particular, for a reply. Okay. And then also we have some information about what we need for a comment. So these are basically schemas you create through Mongoose to tell it what kind of stuff is required for these things. And then you create the index. And then, of course, you're basically compiling the comment schema here, and it creates the Mongoose model named comment. Okay, so that model will provide an interface for interacting with the MongoDB collection. Mongoose pluralizes the model name comment to comments, and we'll use it as the name of the collection in MongoDB. Okay, so we've got that. We need a route also, so we need some express routes so that we can have a REST API. So I'm going to go into, let's make sure we got what we need here. In routes, I'm going to put in comments.js. Here you go. You'll notice NodeMon is trying to keep up with me here. Again, this one's pretty long, so I'm going to scroll through it. So 20, and then up to 37, 54, and then up to 70, and it exports the router here. Okay, so this one basically is just setting up the routes. So for get, router.get, if they put in recipes and then an ID/comments, it'll grab the comments for it. If they do a post at the same location with a specific body format, it will post that information to the database. So this is going to write to the database. So it's using a different HTTP method, and that affects the behavior even if it's the same URL. Same thing here. We post if we want to put a reply or get put the replies there. And so that's pretty much what we've got. Now, the other thing is the server entry point. So we need a server entry point. So I'm copying over the code from that. This one's not very long, this one. So it looks like something blew up. So that's cool. Let's see what happened. Module not found. We will figure this out momentarily. What happened? Let me kill that and then see if Control C will often kill it. Let's see if it gives me another error, because it may be a problem with the code or where I've got it located or something else. Oh, it crashed. It looks like it's looking for .env, which is another .env. I thought I installed that already, but apparently not. Okay, and let's try it again, see if we get an error. Hopefully it doesn't crash this time. It needs .env because that's going to read the .env file. See what else here? Express. Well, that's weird. I thought I installed all of these things. All right, well, we'll try again. We will try that. npm install express. Okay. All right, I thought I did that earlier, but we will see. We'll keep doing it until we get it to go away. Get the errors to go away. Oh, no, we're not there at cores. Also thought I installed that. Isn't that exciting? Okay. npm install cores. So that's for the cross-origin problems that can occur. You want to make sure that you can access it cross-origin. npm run dev. It will eventually stop. This is just showing you some of the errors you could encounter too. I thought I took care of all this. Mongoose. Wow, I thought I did all of that. I must have done something silly. Okay. Mongoose. Okay. All right, it installs Mongoose, and then we do npm run dev one more time. Maybe this time's a charm, hopefully. Oh, authentication failed. Okay, so that means that I've, now at least it's not a problem with a missing library. So we'll go over into the env and see what we have going on here. I think, trying to think what I might have done. Maybe I did something wrong with this. Okay, let's see here. So recipe admin, I'm going to edit the password. So I'm going to enter a new password. This one's just going to be fudge123. Hopefully that'll let me do that. Hit update now. Don't need that. And let's see if it lets us connect now. Okay, now it's listening on port 5000. Awesome. So we can test with Postman now. So this is not, it's not easily accessible just through a web browser, because a web browser is going to directly use Git unless you're using forms and things like that. So to make this easier on us, we're going to use Postman. So Postman is a piece of software that allows us to send various HTTP requests and get responses. So what we're going to do here is I'm going to go under environments. I'm going to create an environment. This new environment, once it's done generating here, I'm going to create this environment and call it recipe API local. And I'm going to give it a variable here. Okay. And we're going to call this base URL. Notice U, R, and L. The U is capitalized, but it's just basically camel case. And for the default, I'm going to put HTTP. I think in the document I put localhost 3000, but we're going to do 5000 because that's where this is running. Okay, that's where the application's actually running. And save the environment. We can make sure we've selected it, though, through the environment at the top. It won't do it by default, so we have to do that. And then in here, we have to go up to collections. All right. And under collections, we're going to create a new collection. And we're going to just, I guess, blank collection is fine. And I'm going to call it recipe comments API. Sounds good. And make sure we save it. Okay. And inside this collection, we're going to add a request. So up here is where I can add my requests. Okay. So I'm going to do that. Here's a request, untitled request. We'll call this one health. Okay. Oops. See if it'll let me select it here. It's being a little bit of a problem here. I don't know why it's not letting me do that. Okay, well, anyway, I'll change the name momentarily. So I'm going to set the URL. We're going to make sure it's on Git. Set the base URL, which it should be pulling from the recipe comments API, right? So it should know what base URL is. It says it's unresolved, so I got to make sure that the recipe local base URL, that's the right name. So let's see here. So I hit enter after this variable name, and that's what caused the problem. So we're now over here, and it's seems to know what it is now, and it returns with an OK true, which is what we want. Okay. Next thing is we want to create another top-level comment. So not a reply, but a top-level comment. We're going to use Postman again. And for this one, I'm going to create this. I'm going to change it to post this time. So we change the HTTP method. And we're going to set the URL. Okay, right here. Again, and that should be turning green, but it seems like it was okay before, so I think we're okay. We have to do a couple additional things, because remember, we're not using query strings or just sending stuff as a basic query parameter using post. This one's, let me see here. This is very strange. It's not letting me change the name here. I don't know that I remember that being a problem before, but we'll see. So we've got post here. I'm going to go under the body. I'm going to change it to raw and change this to JSON. Okay. And then I'm going to actually put some JSON data in here, which we're going to send along with the request. Okay. And it puts the user as A Brown, comment is loved this, and rating is 5. And then I'm going to click send. If it works, which it did, it says 201 created. That's the response, and it tells us recipe ID is 7. I'm going to actually copy this ID in the response so I know which item I'm going to set a reply to. Okay, we're going to need to do that. So I'm going to open the environment again, Postman, and I'm going to create something I'm going to call, well, not something, a variable. We're going to add a new variable here and call it comment ID. Again, camel case. Don't hit enter because I made that mistake before. For this one, the initial ID, I'm actually going to paste this. Well, actually, I got to go get that from the reply, don't I? Okay, so I got to grab that ID, and we're going to put that as the ID that we're working with. And of course, save the environment. So now you're going to create another request. This one's going to be a GET request. And we're going to put base URL /API /recipes /7 /comments, and then click send. Okay, so this is our this request rather using GET shows us that the comment that we had earlier. Now we can make a reply, and remember reply, if I click this, is a post. Okay, so we're posting, and in this case, we're doing the, we're using a couple of the global variables. Okay, so we got base URL and comment ID /replies, right? And we're going in the body again. But this one, this time, in addition to that information, I'm going to go to raw and JSON again, and we're going to put that there. And we can save this. This is where you save the name, by the way. I'm going to put this called add reply. It's using the method post, of course, and then I can hit send after that. See if it works. It does seem to work. And you get the replies there. Perfect. All right, so we can actually verify this information in Atlas if we want to. So we're going to go over to here, and I'm going to go over to the clusters and UMD Web Tech. I'm going to go under the Data Explorer, and I should be able to see my recipes app 1 and go under comments. And you should be able to see the comment and actually click replies, expand that object, and you'll see the replies here. So that's the document that it's created for this. So pretty cool. All right, so that's pretty much what I have for you, and hopefully that was useful to get used to different database technologies, including PHP, MySQL, and also the Node.js and MongoDB. So I hope that was good, and if you have any questions, please let me know. Talk to you later. Bye-bye.